Adult Solutions. Add-on desire.
Hello children, good morning. Welcome to Adult Solutions. This is Ranjit Kumar. So today we are going to start the first chapter in 9th standard, real numbers. Okay, so this is a very important chapter. So real numbers. So real numbers now actually which numbers can be called as the real numbers. Okay, so if you observe the number system, in that number system, what are the natural numbers, what are the whole numbers, what are the integers, okay, what are the rational numbers, what are the irrational numbers, and what are the real numbers. So everything we are going to learn. Okay, so the total basic things we are going to learn in this chapter. Okay, so and in that, okay, what are the rational numbers and what are the irrational numbers, okay, and how we can represent those rational numbers and irrational numbers on the number line. Okay, how to, whenever we having the irrational number in a denominator, whenever we having the one fraction, numerator and denominator will be there. So whenever the denominator is an irrational number, how to rationalize the denominator also we are going to, okay, we have on that, okay, based on that concept also we are going to solve the problems. Okay, and next, okay, whenever we having the two rational numbers, okay, rational number in between the two numbers also we are going to find, and irrational numbers also we can find. Okay, and how we can say without actually what are the terminating decimal, what is the terminating decimal expansion and what is the non-terminating decimal expansion. Okay, and without doing actual calculation, actual division method, how we can say whether the fraction is terminating or non-terminating. Okay, and magnification method to represent the given decimal expansion number, given decimal number on a number line by using the, okay, magnification method, successive magnification method. So everything, and some lots of algebraic identities also involved in this chapter. So everything we are going to discuss in this chapter, and we are going to learn many things. Okay, right. So what is our chapter name? Real numbers. Okay, so before, okay, just I am going to introduce here itself. So first of all, whenever we are going to learn about the real numbers, we have to know the system of numbers. So for example, natural numbers, we know the natural numbers. Okay, natural numbers we are denoting as n. So n is equal to 1, 2, 3, 4, 5. Okay, so like this, these are the countable number of elements. Okay, means countable number of elements. Now just we are using these numbers to count. Okay, 1, 2, 3, 4, 5, 6 and so on, infinite number of okay, numbers are there. Okay, so the natural numbers we are denoted as represented by capital N, and those are started from 1. Okay, and okay, the set of numbers are like this, 1, 2, 3, 4, 5, 6 and so on, infinite numbers are there. In this, what is the least number? Okay, what is the minimum number we having in this natural numbers? 1 is the minimum number, and the maximum number we can't say. Okay, we don't know what is the maximum number. Why? Because we are having infinitive numbers we are having. And next, for example, okay, and whole numbers now, W is equal to whole numbers. Okay, so whole numbers are started from 0. Okay, 0, 1, 2, 3, 4, and so on, infinitive. So these are the set of numbers, okay, which are called as the whole numbers. Okay, whole numbers now, so we can represent these whole numbers by using the capital W. Okay, so W is equal to, now look at here, so 0 is there, 0, okay, plus, okay, all these are the natural numbers only now, n. Okay, now W is equal to 0 plus n. So to the natural number, if you are adding 0 to the natural number, so if you add a 0 to the natural number, then we can generate the total whole numbers. And in this whole number, the minimum value is 0. Okay, the starting value, that is only the least value, that is 0, and the maximum value we can't say. Okay, and integers. Okay, integers now we can represent those integers by using capital I or a capital Z. Capital I or capital Z. So the set of numbers involved in this integers are okay, the negative numbers are there and positive numbers are there, and including 0. Okay, negative number. For example, look at here. So this side, okay, infinitive many numbers are there. These are the negative numbers. So minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on, infinitive. So these are the integers. Okay, so look at here. So if you take one number line, for example, integer number line. So this is one integer number line, for example. Okay, this is 0, 1, 2, 3, 4 and so on. Minus 1, minus 2, minus 3, minus 4 and so on. So both sides, actually this is one straight line, right? So this arrow marks indicates that okay, we can expand that line endlessly on both sides, infinitively we can expand on both sides. So look at here. So these are the numbers, okay, negative numbers, okay, infinitive numbers are there, and positive numbers also, infinitive numbers are there. Okay, so in the integers the middle value is 0. Okay, like that is like origin. Okay, that is the middle value. So the middle value of the integer is 0. Okay, 0 is not a negative integer and not a positive integer. 0 is not a negative integer and not a positive integer. So but it is the mid value of the all the integer values. Okay, now if you observe on this number line, so up to here, so 1 to this side, okay, these are the natural numbers, and 0 from to this side, these are the totally whole numbers, and the total values on the number line, this number line representing the integers. Okay, these are the total integers. Now okay, we know natural numbers, whole numbers, integers, and everything. So next rational number na, just we are denoting the rational number by using q, capital Q. Okay, rational numbers q. Okay, rational numbers are q. Okay, rational numbers are the numbers which can, okay, now we are going to learn about the rational numbers. Okay, actually real number is nothing but, okay, these are rational numbers are represented by q, and irrational numbers means the sets we are going to represent with s. So here the real numbers is nothing but q plus s. Okay, means rational number plus irrational number. So the combination of both the rational and irrational numbers are nothing but the real numbers. So real numbers is like a universal set for all the numbers. Okay, so real numbers are nothing but the universal set of numbers are involved in that real numbers. Okay, so that's what it can be called as a universal set for all the numbers. Okay, so for example, if you observe, so there are so many types of numbers are there. Like, okay, we can divide the system of numbers. Okay, we can divide the numbers into some systems. Okay, like for example, here we divided natural numbers, whole numbers, integers, okay, rational numbers, irrational numbers, okay, and imaginary numbers, okay, and next odd numbers, even numbers, okay, prime numbers, co-prime numbers. So like that, the different numbers, okay, there are some system of numbers are there, some set of numbers are there. Okay, so in this chapter we are going to learn about the real numbers. So real number is nothing but the combination of both the rational numbers and irrational numbers. So which can be called as the rational number, and which number system, okay, the set of numbers which can be called as the sets, that we are going to learn. Sets means irrational numbers. Okay, those things we are going to learn in this chapter. Okay, right. So till here you understood, right? Natural numbers, whole numbers na, that is called 0 plus n. If you add 0 to the natural numbers, then we will going to get the total whole numbers. Integers na, positive values are there, negative values are there, and 0, including 0 also there in integers. So integer can be represented by capital I or capital Z. Okay, and in the integer number line, if you understand this total number system, so on integer number line, just you can keep one less than symbol in between two numbers. Okay, less than. So to the left hand side, the values are gradually decreasing. Okay, so gradually decreasing, and to the right side the values are positive values. So positive values are increasing. Okay, just you can use the less than symbol. For example, here minus 4 is there, so minus 4 is there and 0 is there, so minus 4 is less than to 0, minus 4 is less than to 0, and minus 3 is less than to 1, minus 2 is less than 1. So whenever, for example, if you select a number on a number line, okay, for example, if you select a number on a number line, okay, if you from that number to left side, if you are moving now, that values are decreasing. So from that number to, if you are moving towards right side now, then the values are greater values, all the values are greater value towards right to this number, and all the values are lesser values to the left side. Okay, this basic concept we should know. Okay, right? So today we are going to learn the total things about the real numbers. Okay, so what are the rational numbers? So rational number means the number which can be written in the form of p by q. Okay, so a number which can be written in the form of p by q, where q is not equal to 0. Okay, so if you are taking a number, for example, p by q is a one number, so this is a numerator and this is a denominator, that we know. Okay, so this is a numerator and this is a denominator. So p by q is a one fractional number, for example. So a number which can be written in the form of p by q, okay, and q is not equal to 0. Q means the denominator should not be equal to 0. Okay, where p and q are the integers. Okay, where p and q are integers. So a number which can be written in the form of p by q, where p and q are the integers and q is not equal to 0, are called as what? Rational numbers. Are called as what? Rational numbers. So why the q is not equal to 0? Okay, means the denominator is not equal to 0. Why? Because, okay, why? Because if the denominator is equal to 0, then we can't define it. Okay, so we can't say the value. So for example, look at here, for example, 5 by 0 is there, so the denominator is 0, so simply we can take as infinitive. Why? Because we can't define it. So always the denominator, if you are taking any fraction number, the denominator must be not equal to 0. So if it is equal to 0, then we can't define the value. So that's what, even though you take any number, so for example n by 0 is equal to what? Infinitive. So n may be any number. Okay, n may be any number other than 0. So if you are taking any positive or any negative number, so that by 0, that is equal to something by 0, that is equal to infinitive. So that's what here we are mentioning, that q is not equal to 0. So simply rational numbers now, a number which can be, okay, which can be written in the form of p by q, where q is not equal to 0. So for example 1 by 2 is a rational number. Okay, so rational number now, don't confuse here, don't confuse. Rational number means if you take a integer number line, integer na, so look at here, so 0 1 2 3 4 and so on, -1 -2 -3 and so on, all the integers come under rational numbers. All these are the rational number. For example, if you are taking 2, this can be written as 2 by 1, where the denominator is not 0, denominator is equal to 1. Okay, so for example, if you are taking, for example, 0 is also a rational number. 0 by 1 is equal to 0, that is also a rational number. Okay, so like that, even though you take any integer value from the number line, so all those are the rational numbers. Okay, so even though if you take any single digit or double digits, whatever the number you are selecting, for that the denominator you can write as a 1. Okay, so those are also called as what? Rational numbers. Understood? Okay, so all these are the rational numbers, and the numbers also which can be written in the form of p by q, where q is not equal to 0, are also the rational numbers. So what are the irrational numbers? Irrational number means the numbers which cannot be written in the form of p by q, which cannot be written in the form of p by q, are called the irrational number. Look at here, a number which cannot be written in the form of p by q for any integers p and q, where q is not equal to 0, are called, is called the irrational number. Is called the irrational number. Okay, we can't express that one as p by q form. Okay, p by q form, we can't. For example, look at here, 0.5 is there. 0.5 is a rational number or irrational number? This is a rational number. Why? Because 0.5 na, that is a, okay, that we can write as 5 by 10. 5 by 10. 5 by 10 now again, if you cancel 5 1s, 5 2s, so 1 by 2 will be there. So 1 by 2 is already, we know that is a rational number. 1 by 2 is a rational number. Okay, so the rational numbers you can express as p by q form or decimal form. Okay, so like this, and the rational numbers are sometimes okay, non-terminating rational numbers also will be there. Okay, so all those things we are going to learn here itself. Okay, so now understood, right? So 0.5 is a what? That is a rational number. Why? Because 0.5 you can express as a 5 by 10. So before one digit, if you are having point, so 1, okay, after 1 we are going to get 1 0. So for example 0.05 is in a, so here before 2 digits we are having point, so 5 is 5 by, here 2 digits before we are having point now, so after 1 we have to write 2 zeros, means 5 by 100. So like that we are going to take in a p by q form. Okay, but look at here, irrational number, the number which cannot be written in the form of p by q. Okay, so for example I am taking root 2. Okay, root 2 is a irrational number. Okay, root 3 is a irrational number. Root 4, for example root 4 if you take now, this is not a irrational number. Why? Because it is a perfect square number. Okay, root 4 you can write as 2 square, square root gets cancelled, again you are going to get 2. Okay, so whenever you having root, so this is a square root, right? So this is square root na, okay, inside if this, okay, if this radian is not a perfect square number, If it is not a perfect square number, then that can be called as a irrational number. So for example, root 2 is not a irrational number. Root 2 is irrational, root 3 is irrational, next root 5 is irrational, next root 6 also irrational, root 7 also irrational, root 8 also irrational, but root 9 is not a irrational number. Why? Because 3 is a perfect square number. Why? Because 3 square is equal to what? 9 you are getting, right? 3 square is equal to 9 you are getting. So that's what it is, not a irrational number, rational number. So like that you can write many okay irrational numbers. For example, as an example you can write many irrational numbers. For example, root 2, now that value is called 1.41428, so and so on we will get, and root 3 value 1.7321. So like that you will get some more non-recurring values you are getting. Okay, so for example, even in a decimal form also you can express as a non-recurring values, like, okay, for example 1.01000011000111. Okay, so for example like this, okay, 0, okay, 001 0001. So like that, for example 1 point, okay, 75689328694. So like that. So these are the non-repeating values. After the decimal point, if you are getting the non-repeating decimal numbers, so again this can be called as a irrational number only. Okay, na? So like that. So this one we can't express as p by q, like, okay, like if you are taking 0.5 now 5 by 10, so that is a very easy to express, okay, very easy to express in a p by q form, and we can find the value also. But here we can't write the given values, okay, given decimal form as p by q form. So that's what the number which cannot be written in the form of p by q, in which q is not equal to 0, where q and p and q are both are any integers. At the time we can call those numbers as a irrational numbers. Understood, right? Now the decimal expansion of a rational number is either terminating or non-terminating. Okay, terminating or non-terminating, recurring. Okay, recurring now after the decimal point the values are repeatedly occur. Okay, the same values. So for example, look at here. So for example 2.010101, like that. Okay, if the values are generating like that, so only the 2 digits after the decimal point, only the 2 digits only repeatedly occurring. So that you can write as 2.01 bar upon 2 digits. Now this symbol is bar. So bar, why we are taking bar now? That bar will represent that these 2 digits are repeatedly occurring. Okay, so those values are recurring values. Those values are recurring values after the decimal point. Okay, now look at here. So the decimal expansion of a rational number. For example, if I am taking one rational number 2 by 3. Now look at here, 3. Okay, we have to divide 2 by 3. Okay, 3. Okay, point 0. 3 6 18. So 2 you are getting. So point is there. So 0. 3 6 18. So again you are going to get. So like this. Okay, 6 6 6 and so on you are going to get. So simply 0.6 bar. Here only one digit only repeatedly occurring, means recurring values. Okay, so after the decimal point, okay, even though it is a non-terminating, what is the terminating and what is the non-terminating? So terminating now, for example, look at here. Okay, for example 10 by 5 is there. Okay, simply, okay, 5 2 is 10, 0. Okay, here 2 is there, terminated there itself. For example, here 5 by 2 is there. 5 by 2 now, okay, we have to divide 5 by using 2. Okay, 2 2 is 4, 1 is there, point 0, 2 5 is 10, 0 we are getting. Okay, here 2.5 you are getting, right? So 2.5, after the decimal point, the decimal expansion is over here itself. Okay, so the decimal expansion is over, 2.5 na? Okay, that 5 by 2 means half of 5 will be 2.5. So the decimal point is there, and the decimal expansion is terminated there only. Okay, so for example here, if you are taking 10 by 4, if you are taking 4, 10, 2, okay, 4 2 is okay, 8, 4 2 is 8, na 2, point is there, 0, 4 5 is 20. Okay, now what you are getting the remainder? 0. So here the expansion is over, this is the terminating decimal expansion. But look at here, if you are taking 2 by 3, then 3, okay, we have to divide 2 by 3. Okay, now 3 20. Okay, here I taken. So point 0 we got. So 3 6 18. So again you are getting 18. So 3 6 18. So and so on. So So here 0.6666 and so on, we are getting like that, simply 0.6 bar. Here this is a rational number, even though it is non-terminating, it is a rational number, only after the decimal point only one digit only repeatedly occurring. Okay, there is a recurring value. So if after the decimal point, if the digits are changed, okay, if the digits are non-terminating, non-recurring values, okay, if the digits are not, okay, here look at here, the decimal expansion of an irrational number is non-terminating, non-recurring value. So for example, 7 point, okay, 1 5 6 1 2 6 7 3 2 5 8 9 6, so like that. Okay, so there is no order 1 5 6 7 3 2, so this one we can't express as p by q form also. Okay, so after the decimal point, after here is a decimal point, after the decimal point, the values are non-recurring values are there. So that's what these type of okay, numbers are can be called as irrational numbers. But look at here, 2 by 3, this is a non-terminating decimal expansion. So look at here, all the terminating decimal expansion forms numbers are there now. So all those are the rational numbers only, even though it is non-terminating. Okay, after the decimal point only one or two digits are repeatedly occurring now, those okay, values also called as the rational numbers. Okay, non-terminating rational numbers. So here rational numbers are how many types? Rational numbers are actually two types. Okay, so here rational numbers are two types. What are those? Terminating rational numbers and non-terminating rational numbers. Okay, but here irrational numbers now non-terminating and non-recurring values. Non-terminating and non-recurring values. Okay, understood? Now what are the rational numbers and what are the irrational numbers? You clearly understood, right?
Add-on solutions. Add-on desired.